Hello, my name is Srinidhi Kail. Today I will be presenting on image captioning. This is a topic in information retrieval where computer vision and natural language processing come together and make machines understand and describe image in words. In this area, it will have two major AI fields like seeing and speaking, which plays a major role in intelligent system retrieval organize and communicate visual information. Coming to the next slide, here the list of contains and first one is introduction. In introduction, let's begin with a simple example. Imaging showing a computer a photo of a child playing with a dog in the park, and the system responds, a child is playing with dog in the park. This is the power of image captioning. It's not just identifying objects, it's about understanding what is happening, how object relates, and how to describe the scene naturally. In information retrieval, this ability helps bridge the gap between visual data and textual search. Instead of manually tagging images, captioning allows automatic description generation, which means image become searchable through language. Ultimately, image captioning helps build multimodal AI where systems process both visual and language together. And um, next coming to why it matters. Here we have four different like four different uh, four different types. First one is accessibility for visual impairment, search engines and photo organization, automatic content creation and internet, autonomous vehicles. Firstly, coming to the accessibility, people with visual impairments can receive spoken or written description of online images, improving their digital experience. And coming to the content organization and search. For example, if we have a Google photo, which automatically labeling pictures or e-commerce platform, generating product description. Like all of these examples, retrieval tasks supported by the image caption. And coming to the autonomous systems, like self-driving cars or assistive robots, understanding the scene is crucial for discussion making and safe navigation. And finally, it forms a bridge between vision and language, laying the foundation for today's multimodal retrieval models that can find information across both text and image. And coming to the next slide, how image captioning works. So let's discuss how it actually works. There are two main approaches. One is classic pipeline, and the other one is modern transformer based approach. And next, coming to classic pipeline, as we see, the system has two main parts, an encoder and the decoder. The encoder, typically a convolution neural network such as VGG and ResNet, which extracts visual features like shape, colors, and spatial patterns from the image. The decoder, often a recurrent neural network or an LSTM, takes them features and generate a sensitive words like which generates word by word. If you can think about CNN as the eye of the system and RNN is the its voice. Coming to an example, if image shows a brown dog running on a grass, the CNN identifies the object while RNN forms a caption. A dog is running on the grass. This CNN RNN pipeline worked well for simple scenes but struggled when multiple objects or complex relationships appeared in an image. That lead to second approach, which is the modern transformer architecture. Coming to the next slide of modern approach. Here, in modern captioning models uses transformers, the same technology which behind large language models like GPT. Systems such as Visual GPT, BLIP, or CLIP plus GPT uses attention mechanisms to handle both vision and text jointly. Here, here we'll extract how it actually works. So the image is first processed by a vision transformer that converts different regions, say a horse, a car, a tree, into a visual embeddings. These embeddings are then passed to a language decoder similar to GPT, which generates a caption word by word. The attention mechanism lets the model focus on both most relevant image regions for each word. So, when the caption says a cop riding brown horse next to a truck, the model is actually attending to the cop and the horse area in the image at the moment. Modern transformers also reuse pre-trained GPT style weights, giving them strong language fluency and making the captions sound more natural and human-like. So this is about the modern approach. And next coming to the difference between classic versus modern. Here let's compare two approaches briefly. Coming to the architecture, it has CNN plus RNN, and for modern transformer it is a vision plus language transformer. And coming to the feature handling, so sequential for classic pipeline and parallel with attention for modern approach. And next coming to the performance, good for simple images and for modern it is somewhat complex. And coming to the training, it is task specific and the modern approach is pre-trained multi-model learning. For example, show and tell, show attend tell. And for modern transformer, it's visual GPT, BLIP, LLM. And the classic CNN RNN models build the foundation, but the modern transformer systems generalize far better. But understanding relationships and can even perform zero shot captioning, describing image they have never seen during training. And coming to the next slide, problems and challenges. Here, despite of the all major progress, image captioning have several challenges. As we mentioned here, like understanding multiple objects and their relationship, and ambiguity in constant, data availability and attenuation constant, and evaluation difficulty, generalization. Coming to the complex scenes, capturing multiple interacting objects accurately remains difficult. So, and next coming to the context understanding, recognition, recognizing why something happened, not just what, requires reasoning beyond pattern recognition. Coming to the data availability and annotation cost, since models learn from human labeled datasets, cultural or gender bias can appear in generated captions. And coming to evaluation difficulty, there is no single correct caption for a picture existing. Metric like BLEU or meteor often fails to reflect true caption quality. And coming to the generalizations, models may perform very pure or some like unseen domains or unusual image types. So it may perform like unusual image types or purely unseen domains. So overcoming this issue is a big focus on ongoing research. Like they are they are just overcoming these issues by focusing on the research. And coming to the next slide is the research trend. As we see, we have four different types like vision language pre-training, multimodal large language model, image captioning plus questioning answers, and improving interpretability and bias reduction. Firstly, coming to vision language pre-training. Here, the large-scale models such as the CLIP and etc. are trained on a million of image text, giving them board general knowledge. And next, coming to the multimodal large language models. Here, the systems like GPT-4V or LLaVA can process both image and text, performing tasks such as captioning, visual reasoning, and question and answering in a unfilled model. And next, coming to the image caption plus questioning answers, like it is a research or adapting captioning for specialized areas, for example, medical imaging or a satellite data, where accuracy and detail will matter more. And coming to ethics and bias reduction, like improving interability and bias reduction, a growing focus is on building fair, explainable captioning systems that avoid and ensure transparent discussion making. Together, together, all of this research trends pushing image captioning closer to real world responsible AI applications. And next, coming to the conclusion, and here we are concluding that image captioning is a powerful information retrieval technique. It's a technique that bridge vision and language, teaching machines. That means that teaching machines not only to see but also to describe and reason what they see. Here, here, all of the above, we have progressed from a simple CNN, RNN models to advanced transformer architecture, capable of generating fluent, context awareness, and human-like captions. And next, coming to the impact extended course, the impact which is extended across the things. The coming to the accessibility, search, e-commerce, robotics. It was used in many more domains, like image processing, which they capture the image and they will enhance by using these types of tools in different domains. It will be more useful in military domain too, because like it captures more, it captures more relevantly, and which we can use these tools to reset the or enhance the image. As research continues, image captioning will become even more context sensitive and creative, moving to closer to the intelligent multimodal AI systems. In short, so this is the information retrieval, computer vision, and natural NLP combining. So, coming to thank you.